Hello everyone, let's look at our next problem. It says, provide the skeletal structure for CH3, CH2, CH2, COOH. So let's recall how we draw skeletal structures. We recall that every line segment is a CC bond. So CC bonds are line segments with every end of a line segment. Usually these ends of the line segments are corners, but sometimes if we're indicating, for instance, linear geometry in a triple bond, it might just be the end of that line segment. Hydrogen atoms, and I wrote specifically in CH groups, are implied based on carbon atoms having 4 bonds. So you know every carbon needs 4 bonds. Anything that is not, if you only see 2 bonds or 1 bond, then you can infer how many hydrogens are present. Obviously, hydrogen atoms on other atoms need to be specifically indicated. So let's look at the condensed structure we're given. First, let's start with how many carbons do we have? We have 1, 2, 3, 4 carbons. There are no parentheses indicating no branches or repeating subunits or anything like that. So just straight 4 carbons in a main chain. So we'll draw in a zigzag shape, 1, 2, so that one line segment indicates a bond between carbons 1 and 2. And bending down, that would be 3, 4. So we've got 4 ends of our line segments with 3 segments themselves, so 3 bonds between our 4 carbons. Then we have 3 groups of CH atoms. We have that CH3. So looking at the terminal carbon, looking at the number of hydrogens in the structure will tell us, do we have any pi bonds? Well, this is carbon 1. It's at the end. It needs 4 bonds. It only has 1. So there we would expect 3 hydrogens. So no double bond there. Then the 2 internal carbons, they have 2 bonds already to other carbons. So you'd expect 2 hydrogens, and indeed they're each indicated as H2. Then finally, our final grouping is this COOH. And this is just a pattern we should recognize as a carboxylic acid when it is written in this fashion. And the carboxylic acid group, we have a carbon or carbons attached to something else. It has a double bond to an oxygen, so it has a carbonyl group, and then a single bond to an alcohol group, so to OH. So on our skeletal structure, the end of that line segment is that carbon 4. It has a double bond to an oxygen, so we add our double lines to make that double bond to an oxygen. And then we have a single bond to another oxygen. So bring that down as another zigzag. But this time we write in the oxygen because obviously it's not a carbon, it needs to be specifically indicated. And our oxygen has a bond to a single hydrogen. Because this isn't a CH grouping, that also needs to be indicated. But we can just write it as OH. We don't necessarily need a line there. It's implied that oxygen has a bond to the hydrogen. So there's our skeletal structure, showing our 4 carbon chain, all the hydrogens attached to carbons being implied, and our final carbon having a double bond to an oxygen and a single bond to an OH alcohol group. See you in the next video.